Hello everyone, April the 10th. Alright, let's do it today. Let's take a look. Nothing here. Alright, I expect something difficult today. Take a look. Longest increasing path in a matrix. Alright, I don't like this. Matrix is not my favorite. Finding a path is definitely not my favorite. But let's take a look. Given a matrix, return the length of the longest increasing path. Oof. For each cell, you can either move in 4 directions. You may not move diagonally or move outside the boundary. Wrap around is not allowed. So 1, 2, 6. Okay. So it doesn't matter where you start. So you always try to start from a small value, right? Moving diagonally is not allowed. Yeah. So, oh God, what's the length? 200. Okay. The longest increasing. So, well, usually dynamic programming. Let's think about dynamic programming. How can we? I mean, for any cell, right? It's either in the path or it's outside a path, right? So we can say for each cell, we're going to find the longest path that's starting from the cell. And for this, you look around, nope. This one, if I go here, then we know it's nope. Then that's 1. That's actually 2. So this is 1. This is a 1. And this one will be, I mean, there's no direction to start from. So then this one will be 2. And if I look down, I need to know what is this value. So one way, like I don't know, so I have to go down here to know first, and then I can know this. So I go down here, and then look around, that's nothing. So I'll go back here, that's good, and we'll keep going down here. This one, go up, there's 2, no. So this is strictly increasing. Yeah, otherwise I can go this way. So strictly increasing. So not working. This one we can go up. We only go up, so this one records as 2. This one is a 2, right? And this one we're already done. We're gonna do it again. Coming down here, we're gonna go up. That's 2, so it becomes 3. Go up is 3. Can now go. This one 4. Can now 4. This is, yeah, we can do. Oh, maybe that is the way to go. I'm not sure. It does. I mean, it's not completely. I'll say it's not completely. Well, we have it. It has a. What am I call it? It has a recursion part to it, right? So basically, we look at each one, and each one we're gonna try to branch out, and we can branch out 4 directions. And then each time we branch out, but each one will only be visited once, because once we visited it, or recorded, and then that one will not be visited again. Yeah. Let's try this one again. So can now go. So this one will be 2. This one will be 2. Oh, what are you gonna do with this? No. This one will be, I don't know. I haven't done this one yet. So we hold, and this one I'm gonna go. Hold. This one I'm gonna go. Hold. This one. That's 1. So return here. This one will be 2. Return here. This one will be 3. Return here. This one will be 4. Okay. After we've done this, we move on to this one. We visited already. This one visited already. Coming here. Boom, boom, boom. No go. Here. 2. It's actually no. It's actually 4. So this is 3. So that will be 3. That will be 2. So this one will be 4 as well. And then this one fixed it already. This coming back, coming up, will be only 2 because this one's 1. This one nowhere to go. This one can come back, come here, both are 2. And then we just need to record the longest. I think that is the solution. All right, let's code it up. I don't know what I was thinking earlier. All right, let's do this. So what do we have here? We have this, so a little bit recursion, right? A little bit recursion and a little bit dynamic programming. So this is this. All right, so what do we need? We need dp and mn equals len matrix 0. Okay, so that's dp equals 0 times number of columns, and this is number of rows. Okay, so when this is done, we're gonna say dfs, right? What do we need? We need index I and j, all right, current I and j, and that's about it, and that's the only thing we need. that's the only thing we need. So we're gonna say if dp I and j return dp ij. All right, so that's just the maximum. I'm gonna return int. Let's put some hint here. That's gonna be int. And this is going to be int. All right. So if it's 0, that means we haven't visited before. Now we're gonna visit it. How do we visit it? We have 4 directions. We're gonna put directions here. So this is dirs equals. So we're gonna go up. What is up? Up is 0, 1. No, 0 minus 1. No, minus 1, 0. No, minus 1, 0. Yes. Let's go up. What's the next? So we have up to the right. What's to the right? To the right will be 0, 1. And down, what's down? Down is 1, 0. What's left? Left is 0 minus 1. All right, so this is dirs. So I'm going to say for di dj in dirs, ni and j equals I plus di, j plus dj. That's the same as I've been coding this for the past week in the grid world reinforcement learning. So it's exactly for the same logic here. So now we're going to check for the di dj. So what we're going to check is we're going to also have a max. All right, I'm going to have a max len for 0. I actually don't need max lens. I know. So I'm going to say let's do it here. If do we check before we go? Let's look before we leap. All right, we're going to say if 0 smaller equal to m, ni smaller to m, and 0 smaller equal to nj smaller to n, then we're going to do dp ij, right? dp ij equals, well, that is not starting from 0. That's starting from 1. So if we can go to the next one, then we say this should be equal to dpij. Yes, dpij and dpij plus dfs ni and j. All right, and then we go all four directions. After we go all four directions, we're gonna return dp ij. All right, that's the DFS. Now we can say we'll try to visit every single one. Res is gonna equal to 0, and then we say for I range M. Actually, yeah, for I in range M. I think something is wrong. Yeah, I know something is wrong. Something is wrong here. We cannot go immediately. We have to be this and matrix. I forgot about this. Ninj has to be larger than matrix ij. Otherwise, we do not go. So it has to be increasing, right? Then we go. Now we can say res equals max res DFS ij. Then at the end, return res. Alrighty. Test this to see if we got it right. So this is our matrix. Copy and paste here. Some answer is 4. This one answer is 4 as well. Okay, this one answer is 4 as well. And we also have, this is a special case, answer is 1. Okay, and then we're gonna fix all the commas. So we don't like to have we want to have spaces between commas. So we're gonna go matrix here, and the solution will be longest matrix. Try it. Hey, that's not good. All right, what is wrong here? It's like we're not incrementing. All right, let's take a look. Every time a DFS, let's print out every time. Let's print out the DP. Right? Let's print out DP. See how it looks like. DP is not changing. Why it is not changing? I don't know why it's not changing. This should change DP, right? And it's not changing. We start from 1. Okay, let's try to see. We are here. And oh shoot. I realize why. Why we have to set it as 0, because it's just we have to do equals 1, right? Otherwise, I need this as a sentinel. We need a sentinel. All right, then we're recording and we have a wrong answer. This is actually even worse. All right, what we have? Some have 7. What the hell? 7. Okay, we need to print it in a better way because I really cannot tell what's what. For row in DP, print row, right? And between each print, and also separate them with a little bit this, so we can know which one's which. All right, so starting is good. 1, 1. This, how is this one 3? Because this one's 1, and then so itself. Hold on. I'm a little bit confused. Oh, I think I know. I think I know. Seems like we do need a separate. Max len equals 0, which is 1, right? I can do this. Yeah, because each time when we go to a new direction, we should not record in this. We'll do this, and then every time we are going to do max. Hold on. A little bit confused here. So every time we're going to use what I currently have, and then plus what's going to return to me, right? This is the longest. So we're here. Every time we're here, it's always going to be 1, because if we want to do it, it's always going to be 1. Right? Because every time we haven't visited, it's always going to be 1. So I just need to do 1, because that's what I am right now, which also means we don't need this, right? We don't need this, and that should be correct. Yes, that is correct. Okay, now let's try the other two and comment out this. All right, we all passed this test cases. All right, let's take a shot. See how it goes. Submit. Pending. Judging. Accepted. Nice. Got it. So this is actually the ON solution. Let's see the runtime, because we only visited each cell once. Yeah, that's about right. Okay, so this is a DP solution. For each, we record the longest path that at each position, like at each cell of the DP table, we record the longest path that starts from the value in that cell. And as we iterate through the entire matrix, we can build up the DP table, and the result will be the max of the DP table. Right? ON, since we visit each cell only once, and we run this at 452 milliseconds, or 75% ranking. All right, I think that's probably is the solution, the right solution. Let's take a look. I think this is medium. Pretty confident. This is not going to be easy. I think it's a medium question. Ooh, this label is hard. I'll say it's all right. I mean, it seems okay because we immediately found the right solution, and also I've been doing this great word stuff for a while, so kind of already accustomed to how this one sets up. Oh, DAG. He can use DAG. Let's see what Stefan Pachman. Bottom up DP. Okay, I want to see what bottom up does. A memo and the max. Complex number. What the hell? He used complex number? Huh? What? Oh my dear Lord, he used a complex number. Wait, what? Wait, what? This is ridiculous. Complex number. Oh my god. Wait, does Python supports complex number? I didn't know. All right, let's take a look. Max, yes, yes, it's the same. Yeah, it's the same thing. But he just writes everything in one line. That's Mr. Parchment being Mr. Parchment. He likes to write it that way. I do not condone that, but there's nothing I can say. I mean, he is him, right? Oh man! Oh, look at this. Oh, that is purely interesting. So you take the value out into, turn the matrix into this, therefore, and the memos also, right? And then they call this function on this matrix, and then we map everything in matrix, and then we find the max. Okay, so for length, well, each one, z is not in memo. Yeah, that's the same. Max. If z matrix, that's why he uses. So he doesn't have to check this, right? Doesn't have to check this. He just do z matrix, and then this is the same. Yeah, he doesn't have to do this. It's just like single level. Okay, all 0 or nothing, right? So if this, if not this, we're gonna return z, and here if this, and this is nothing, we'll return this is 0. Okay, yep, that makes sense. Otherwise, you sort, because now you can sort it. You can start from the smallest. Wow. So we sort it, and it will be this one, the smallest. Oh dear. Oh dear Lord, this is good. This is so good. I think we're gonna write down the complex number. Yeah, I need to check. This is bonkers. This is bonkers. Python supports 1 plus 2i? No, it tells me syntax. Oh no, that's not I. 2j, 2 times j. No. Wait, how do I do this? No times. Oh, yeah, they do. Oh, this is a complex number. What's the type of this? Type complex. Oh wow. Oh wow. This is what's the documentation on this? C math has complex. That's built in, right? Nice. Oh, z real, z dot imagine, and 1j. Well, you can call complex, and then you can turn it direct to polar. Wait, do we have to import CMath? Yeah, I think we have to import CMath to do all this. Complex math, I think that's what it stands for. For complex numbers, yes. Complex number is stored internally using rectangular or Cartesian coordinates. That's real and its imaginary part. Wow. Today I learned. Yep, that's exactly. Today I learned complex number exists. Well, it should exist, right? Wow, this is very, very good. Yeah, because the bottom-up solution does require sorting, and you cannot sort if you don't have a way to combine. I mean, we can, right? It's possible to sort, but the sorting requires also the index, right? So it's not just the value itself, but also the index. So you need to create, I mean, it's possible. Each index, yes, it's possible. We can sort, we can sort, we can sort. Yeah, it's a pretty standard solution. Let's see the DAG. What's DAG? DAG is directed acyclic graph. Longest path in the DAG. Topological sort. Using Kahn's algorithm to implement topological sort. Counting the levels. Wait. Ooh, that's. Oh, memo DP. Okay. What's topological? I've heard of this before. Topological sort. Corner cases, directions, rows, columns. In degree indicates the number of adjacent cells bigger than matrix. Okay. So we have this to record the number of adjacent cells that's bigger than this, okay? Add each cell with in degree 0 to the queue. So these are the starting point. No, these are the, wait, it's a bigger, these are the end point. Right, these are the end point. Topological sort. So I pop this one out. Right, I pop the one out, which is the one that does not have any, as the last one. And then, yeah, and then I from 0 to the queue size. All right, we'll go through the entire queue. Yes, because it's BFS, so we pop each one out. All right, and then pull. We get the current. We get the front of the queue. We get its positions, all directions, and then if this is just condition, if this one's smaller than that one, which means we can go from XY to the next one, what are we going to do is and in degree equals 0. So we are trying to find, hold on, why would we do this? And in degree, what's in degree? In degree is the number of cells that connect can lead to, right? It's not that bigger. Number of cells that's bigger than me. So if in degree is 0, then I offer. What if the in degree is not 0? Which means I have more. Then what? I don't consider it. How is this gonna work though? Length plus. Hold on. This doing each level. So the first level is in degree is 0. Second level we want to find in degree is 1. And the third level we find in degree is 2. All right, that's the idea. And then if we do this topological sorting from the outside, we're coming in. like level by level, level by level. Then the depth. Yes, yes. Okay, I see. I see where this one's going. We want to find the depth of this DAG. The depth of the DAG is the solution. Longest path, it's the depth of the DAG. So that's why each time we have to find this, which is just restricting for the next level. It has to be in degree has to be 1, right? So we start from in degree is 0, which means you are the largest, and then we're trying to find the second largest number. Good to know. Good to know. I think I've solved. I shouldn't say solved. I think I've seen a problem before that utilizes this topological sort. Interesting. Interesting. Quite interesting. All right. Yeah, I will go with algebra. It's kind of easier on my thinking. Anyway, so that's the DAG solution. Anything else? I think that's about it. I do want to do one more solution here, because what we did is top down. I think we can do a bottom up as well. Like I said, a bottom up is all about sorting. Right? So sort when it finds the smallest, right? So just basically have to turn matrix into something else. Right? How do we do this? How do we do this? We can do so sort based on value, but no, we're gonna do turn the matrix. So turn the matrix into a 1D array, like one-dimensional, with the first one being the value, second and third will be the index, right? And then we start from the first one, and wait, we can start from the first one, and then trying to find. No, then we have an issue. We don't know, right? We don't know if it's going to lead to anywhere. It will be bifurcate. So we have to start from the biggest value. But that's not what Pacman does, right? What he did is just sorted. How could that be true if you just sorted and it goes through the algorithm? If you don't do any, I think you have to start on the biggest, because the biggest is deterministic, right? The biggest is deterministic, and then you found the second biggest, and then just look around, see if anybody's larger than you. Yeah, it has to be reversed. Anyway, we're gonna try this. So, has to be dp as well. Yeah, dp is going to be equal to, I'm going to do, these three is going to be exactly the same, all right? But we're going to treat matrix a little bit. So we're going to say m, what do we say this? Flat m, all right, equals going to be for I row in enumerate matrix, for j v in enumerate row, and we're gonna get vij. So flatten it. After we flatten it, then we can say flat m dot sort, and reverse equals true. So the largest v will come to the first. And then we can say for vij in flat m, right? Actually, we can do in sorted. lat m reverse equals true, and we don't need to do this. Then we're gonna say this thing, right? This thing, and right. I mean, in that case, we probably can start from 1, because it's impossible that you will encounter a cell that you haven't visited before. So we can just set it to 1, and then we just for all this, and as this if this and this one larger than this, then this one equals this, and then 1 plus, it's not DFS, it's just DP, and INJ. Yeah, I think that's about it. And that's the finish. When you return the maximum, let's also have a result here so we can keep track on the maximum as we go through. So every time we do this, after we do this, we're going to say res equals max res dpij, and then eventually we're going to say return res. Let's try it, see if this one works. Yep, it works. So I'm going to submit this. This is bottom up solution. And we don't use this. Submit it. See, it's faster. Bottom up is faster because we don't have the overhead of recursion. That's cool. I just want to make sure that he sorted. I don't really think. No, I don't think he sorted. How'd you figure? How can you sort it without reverse? If you don't sort without, like, you start from the smallest, right? You start from the smallest. I don't understand, honestly. How can you start from the smallest? In the matrix, oh my god, I have a small z and big Z. Jeez. So we sort this, key is get, right? So then what coming out, Z is the smallest coming out. And then we say length Z is 1 plus max, 4 directions, right? Z plus 1 minus 1, okay, this is the next one. If Z in matrix and matrix Z is larger, current is larger than the next. Huh. Oh, I think he's doing a reverse. So instead of checking, so this is the current, right? What we're trying to see is when the current will go to someone bigger, and what he says is going current to someone smaller. Yeah, it works. It works. So basically, we go it the different way. Instead of going increasing, he's doing decreasing. Yeah, that's the trick. We're going to do doing decreasing. If we want to do decreasing, we need to start from the smallest. And it works. Increasing, decreasing is the same thing. All right, good. 2 solutions, bottom up and top down. We're now going to implement the DAG. That one looks complicated to me. We understand how that one works. Hopefully in the future, if we encounter something that requires to use DAG, I will be able to come up with the topological sort. All right, anyway, that will be it. Pretty good, pretty good. Well, it is supposedly a hard question, but we kind of hit on the nail on our first attempt. So that's always good. All right, that's it for today. See you guys tomorrow. Adios.